Welcome to Star Energy Geothermal Wayang Windu Power Plant. Geothermal power plants utilize thermal energy from the hot geothermal fluid to generate electricity. Hot geothermal fluid, which is a mixture of steam, hot water, brine, and non-condensable gas (NCG), is supplied from the reservoir, which is located at approximately 1 to 4 kilometers below the Earth's surface, through the production wells, which are 1.5 to 2.5 kilometers deep. At the surface, the fluid is delivered via pipelines into the separator, where the steam and NCG is separated from the brine. These pipelines are called two-phase pipelines because they are designed to transport a two-phase mixture of steam and brine. In the separator, by effect of fluid cyclonic motion, the brine, which is the heavier fluid, is thrown out to the wall by the centrifugal force and falls down to the bottom because of gravity force, leaving the steam, the lighter fluid, at the center and top of the separator. The brine, which is still hot and contains some harmful chemicals, is then returned to the reservoir through a brine injection pipeline and injection wells. Re-injection of the brine protects the environment from any negative impacts associated with the brine properties and assists in supporting the performance of the reservoir. The steam extracted from the separator is further processed to improve the steam dryness and steam purity. Pressure safety relief devices, which are the second level of protection, operate if the vent valves are not able to release the excess steam pressure. Pressure safety relief devices provide the most reliable and fail-safe overpressure protection, which ensures the safety and integrity of the piping system. Scrubbers remove small quantities of fluid which are carried over in the incoming steam by effect of cyclonic centrifugal motion as applied in the separator. It gives steam output which is pure and dry saturated. The steam from the scrubber is directed to the balancing header before being delivered through a 36-inch main steam line to the turbine inlet, and partly goes through a 10-inch line to drive the gas removal system. Wayang Windu Geothermal turbine converts the thermal energy contained in the geothermal steam into mechanical energy which spins the generator. The steam enters the turbine via two inlet pipes which discharge into a donut-formed chamber. This chamber is called the turbine inlet steam chamber and is located in the center of the turbine. From the turbine inlet chamber, the steam flows into two axial directions through a series of moving turbine blades and stationary blades. After the steam has passed through all the turbine blades, it is discharged into a large vessel which is called a condenser. Within the condenser, the steam is condensed by continuously spraying a large quantity of water into the steam. This causes the steam to be rapidly cooled and changed from steam into water. The water steam contains approximately 1% of non-condensable gas (NCG), which cannot be condensed to a liquid within the condenser. Therefore, the gas removal system is needed to suck NCG from the condenser. The gas removal system is a hybrid system which has a first-stage steam jet ejector and a second-stage liquid ring vacuum pump. The NCG is transported by a pipe to the cooling tower and discharged into the hot air flow above the cooling tower fans. The gas is then mixed and diluted by the hot air flow. The turbine is coupled to the generator, which converts the mechanical energy into the electrical energy. Electricity from the generator is supplied to the PLN high-voltage transmission system via the step-up transformer.